Hi there, my name is Stephen Fields, and today I will be going over the paper Message Passing Attention Networks for Document Understanding, hereby mentioned as MPAD. First off, what is document understanding? Document understanding is an AI task focused on automating the classification of documents and extraction of information. This method works great with structured or unstructured documents as long as there is enough text for the AI to find patterns or phrases throughout. Document understanding has numerous use cases throughout many fields. One example I've myself encountered at my job in the financial sector is with mobile deposits. We use document understanding to scan checks or money orders in order to get all of the relevant information we need off of them without our employees having to process and enter all of it. So for our end users, it's as simple as taking a picture or two of the document and pressing upload. In this paper, the authors go over a method of utilizing graph neural networks for NLP tasks. As noted in the paper, graph neural networks have only recently started to be looked at as a viable method for machine learning, but have already shown strong results in areas such as bioinformatics and social networks. Message passing is a special form of graph neural networks which has two phases, an aggregation phase and a combination phase. This allows message passing neural networks to capture the topology of the graph as well as the vertex representations. The MPAD model is a variant of message passing designed for document understanding. The figure to the right is a graphical representation of the steps MPAD takes, taken directly from the paper. First, the document is represented as a co-occurrence network with an n-gram of 2. Simply put, each unique word is represented as a node by the graph, and the edges are placed between two nodes if they appear together at least one time. The graph also has a master node that is linked to all other nodes. Second, for the message passing portion, each node in this model has a weighted average calculated based on the node's neighbors. Traditional message passing frameworks tend to use a weighted sum instead of a weighted average, but the authors found that the weighted sum is better for their use case. Third, the final step of the model is known as the readout. Their readout uses a global self-attention mechanism, which they derived from an entirely separate paper, so unfortunately I won't be able to go too into detail with this part. For the results of the MPAD model, the authors have provided a lot of information both on the training they did and the results they saw from testing. At the time of publishment, the authors saw results similar to state-of-the-art or state-of-the-art for base MPAD. They also provided several variants of MPAD that also provided state-of-the-art results. As of the time of this recording, MPAD Path, one of the variants they provided, is currently still number 1 on Papers with Code for 3 different document classification datasets: BBC Sport, NPQA, and the routers. I welcome you to pause in order to take a closer look at the results they provided in their paper. While the authors of the paper didn't include any challenges they faced, they did mention a few ablation studies they performed. For those who don't know, ablation studies are studies done to see what happens to the model when they remove certain hyperparameters. I want to preface the following by saying that when I mention performance, I am speaking of training time, and I will refer to accuracy as results. Starting with the number of MP iterations, for this study, they changed the amount of message passing iterations. And as you can see in the table, 4 iterations provided the best results. However, past 2 iterations, they saw a decrease in performance, so they kept it at 2 iterations going forward. For undirected edges, they saw better performance on the routers dataset, but worse performance for the other 2. When using no master node, they saw worse performance on all datasets, and the same thing happened when they used no renormalization. For neighbors only, they ignored the feature of the node themselves and made changes to each based solely on its neighbors. This caused performance to suffer. Finally, without master node skipping, they saw better results on the polarity dataset, but worse results on the other 2. For future directions, as previously stated, graph neural networks have only started to be looked at as a method for machine learning, and this is just one implementation of them. It's entirely possible the authors overlooked something that will boost performance or accuracy. Along those lines, while 4 iterations did cause a slowdown when they ran it, computing power is still seeing major increases year over year. So in a decade, 4 iterations might be deemed too little. As for document understanding as a whole, MPAD is just one method of performing it, and I'm very intrigued to see what advances will happen in the future. Lastly, here is a reference to the research paper. I hope you enjoyed and learned something new, and have a great day.